Hello, this is Chris Wenker. I'm a GIS epidemiologist at the New Mexico Department of Health. This is a training video for the IBIS Community of Practice. I'll demonstrate how to use ArcMap to simplify and generalize a shapefile as part of the process of creating a GeoJSON map layer. Shapefiles, like lines and polygons, are geographic features that are made up of vertices that are connected by line segments. Each vertex represents a latitude-longitude coordinate. The relative density of vertices controls the amount of detail and precision in the line and polygon. As more vertex coordinates are stored for each feature, the file sizes also get larger, and larger file sizes can slow down web performance in Leaflet and IBIS. So our goal is to simplify and generalize the features by reducing the number of vertex coordinates while at the same time preserving the shape of the lines and polygons as much as possible. Here, we're looking at an original Census file and then 3 more generalized versions. Statewide, we don't see any real difference, nor at the county either. We start zooming in on a complex county boundary, and we start to see that the yellow version has probably been simplified too much. Here, the green is the original, the gray was simplified with offsets up to 100 meters, and the pink with offsets up to 50 meters. There aren't any hard and fast rules for what's acceptable. The degree of simplification depends on the scale and the purpose of the map. The balance is between making a feature very simple and losing too much accuracy, and sometimes it takes a few iterations to find the happy medium. For this demonstration, we'll assume that our workflow will use ArcMap to modify the shapefile and create the GeoJSON. That means in this workflow, we'll need to do all the preparation work up front because ArcMap doesn't have any tools to modify the GeoJSON after it's exported. As a side note, in a different video, we see there actually is a way to edit a GeoJSON using QGIS software, but in this video, we'll just stick with an ArcMap workflow. So here's a raw Census shapefile that I downloaded. Now we want to simplify the vertices. In the Advanced Editing toolbar is a Generalize tool, but this tool provides very little control over the output parameters, and the output boundaries between adjacent regions may not match exactly, and it also makes changes directly to your input data, so you have to be careful not to save changes that you may not want. This tool isn't recommended. Here, in the toolbox, under Cartography Tools, Generalization, we have a couple of options. We might try Smooth tools, but those don't fit our needs either. The Smooth tool does a great job of smoothing out jagged corners, but it actually increases the file size, and it also doesn't have a built-in error resolution feature. So we want Simplify instead. Simplify Line for if we're working with roads or rivers. We're working with polygons, so we'll launch the tool. Input our shapefile, set the output, and we'll use the default setting here of point remove. So in the past, working with New Mexico files, I've had good results setting the maximum offset to 25 meters. With some files, I've also had to expand the distance to 250 meters. While I was testing this Montana file, I found that 50 meters provided a good compromise, as we saw earlier. I should mention one side note here. I've occasionally encountered a shapefile that was in a geographic projection that prevented any distance selections here except for decimal degrees. In those cases, I found it better to reproject the shapefile to a new file in a different projection, like UTM or state plane, and then run the simplify on that file, and that allowed the selection of meters or feet. And then we especially want to set this tool to resolve its own topological errors. We want the tool to automatically fix the errors, because otherwise it's entirely possible that the output file might have gaps or overlaps between the adjacent counties. So this setting prevents that. Running the tool. And we've created a new simplified version. Let's look in Arc Catalog. And we can see that we've substantially reduced the file size from over 3 megs to just under 400 kilobytes. And the 50-meter setting looks like it preserved a decent amount of detail. So now, as we've seen in previous videos, we can edit the attribute table of this file to add the geo ID and the title fields that we'll need later, and delete all the unnecessary census fields, and then we could export this as a GeoJSON for a choropleth layer. Finally, I should point out one big consideration. If you're building a set of geographies that are all supposed to nest within each other, let's say you want to have a set of map layers that run from small areas such as census tracts to counties to regions. And all these geographic areas share some common boundaries, moving from small to large. To produce a final set of layers where all the common boundaries are exactly coincidental, you should start with a file of the smallest region you'll be using, like census tracts. So process these polygons with the simplification tool that we just discussed, and then once you have an acceptable product, then use the merge tool in ArcMap to produce merged layers of the next larger area, and then merge those resulting file, that file into the next larger area, and so on. And then when they're superimposed, the final set of layers will all share coincident boundaries because they all derive from the simplified version of the first file that you processed. Now that we've simplified the features and the attribute tables are properly structured and we've exported the GeoJSON, but we're not done yet. We can still discuss other ways to reduce GeoJSON file sizes by text editing, which is covered in another video. We hope this introductory video about IBIS mapping has been instructive. Please check out the other videos in the IBIS Community of Practice YouTube channel.